Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia. This podcast is the final part in our series with Professor Michael Reagan, chatting about automated and autonomous vehicles. Professor Reagan is continuing his discussion on the critical human factors and ergonomics issues and challenges in automated and autonomous vehicle delivery.
The next issue I wanted to talk about was the area of cooperation. In current generation vehicles that aren't automated, drivers cooperate with each other to signal their intentions and avoid crashes. And that's why, even though the road toll is high in Australia, I mean, as I think I may have mentioned, we lose about 1,200 people and probably 30 times that many are seriously injured to the point where they're in and out of hospital for the rest of their lives in many cases. But they are statistically rare events crashes. And the reason is because without us even realising, we often cooperate with each other to help each other to avoid crashes. When people learn to drive a car, typically what we learn from driving instructors and our parents and others who train us is sort of self-defense. How we can avoid ourselves crashing into other people. It's more about hazard perception and responding to potential hazards so that we don't get killed. But probably the most important skill that isn't trained, and I've talked about this publicly before, but I don't think there's really been any research on it that I can tell, is that when we become more skilled, we create, through cooperation with other drivers, an accident avoidance space for other drivers. So if we, for example, are overtaking, we're travelling along and a car in front of us overtakes a car, for example, and we can see that there's going to be a head-on crash because that car in front of us didn't leave enough room between it and the oncoming car, we'll instinctively, as experienced drivers, sort of back off so there's enough space for the driver to get back into the lane in front of us. And if we're in other situations where we can see that there's going to be a crash, we'll do something to minimise the likelihood that other vehicles will crash into each other. And so this is a big issue for highly automated and connected vehicles, that what we need to do as human factors, people as a profession, is to work with the engineers who are designing the algorithms for these vehicles, to help them to program into the vehicles algorithms that will allow the vehicle to cooperate with other vehicles to signal their intentions and to avoid crashes. And at the moment, because connectivity between vehicles is only in its infancy, and because we know that, as I've talked about before during the podcast, that connectivity ultimately will be needed to exploit, fully the capabilities of automation. These sort of things become very important. So it's all about, what can we do based on our knowledge of how people cooperate in non-automated vehicles, how we can convey that information in a way that allows automated vehicles in the future to cooperate in the way we do. Another human factors issue that is, ultimately critically important to address in this whole area of automated vehicles is what we call driver acceptance. And just a few years ago, I wrote a whole book on driver acceptance of new technology, and the essential point that I was making pretty much in that book is that if automation is unacceptable to drivers, in other words, if they don't perceive the automation to be reliable, or useful or satisfying to use, they might refuse to use it, or they might misuse the automation, or they might actually abuse it. And if that's the case, the automation won't have any safety or other benefits of the kind that I talked about earlier in the podcast. And so, ensuring that if, of course, there's evidence that the systems can improve safety and comfort and make life more satisfying for people who drive these vehicles, partially automated or fully automated, then it's our responsibility, advocates for the human factors and ergonomics community, to promote these systems so that they have the benefits that they should. One of the things that's interesting is that we know that not all drivers will want driving tasks to be replaced by automation. Some of the research I've done, which I'll talk about towards the end of the podcast, shows that there are quite a number of people who still want to be able to drive vehicles manually, even if the vehicle's fully capable of driving in fully automated mode. And that raises all sorts of interesting issues, because we talked just a minute ago about loss of skill. And so if you've got a car that in which you can flick a switch and drive the car manually whenever you feel like it, but you've been driving in automated mode or fully automated mode for the last 2 months, that transition back to manual driving may be a real issue from a safety perspective, because of the loss of skill that might have occurred, for example, during that period. So vehicle manufacturers who I work with and have worked with, during my career and still currently work with, will tell you that ultimately they will provide the customer with what the customer wants. And if the customer wants to be able to take back manual control of the vehicle, that's what they'll let them do. And so it's a big issue, and it's one of those issues that hasn't really been explored, as far as I can tell, in the professional literature on human factors and ergonomics. At a broader level, we can talk about societal acceptability. So we talked just now about driver acceptability, but at a broader level, as human factors professionals, and safety professionals, we're also interested in societal acceptability. In other words, what do Australians think about automated, driverless and connected vehicles that we talked about before? And when I was working not so many years back, for a couple of years with the Australian Road Research Board, we set up a small organisation called the Australian Driverless Vehicle Initiative, or ADVI. And within ADVI, we had what we called a scientific research group. So ADVI was just a bit of an offshoot of the Australian Road Research Board, but it ran under their auspices. And they had several subgroups, and one was the scientific research group, which I happened to lead. And we conducted a national survey. In fact, a couple of national surveys while I was working there, to try to understand the level of driver awareness, driver opinions, and their likely acceptance of automated and driverless vehicles. And so we conducted a survey in both Australia and in New Zealand, and had more than 6,000 people that we surveyed. It was really quite a large survey, and that was back in 2017. So, about four years ago now. And it's interesting, some of the findings that came out of that survey. As we expected, most Australians and New Zealanders were aware of most automated vehicle functions that we have talked about today, mainly driver assistance systems like adaptive cruise control and lane keeping assist and forward collision warning. But very few had actually experienced these systems. And I'd still say that's the case today. If you ask the average person if they have heard of these systems, they'll tell you yes, but they won't have them in their cars. They're only just starting to percolate their way into the vehicle fleet. There was we also found there was a high level of community concern about many issues relating to completely self-driving cars. One of the major red flags for people was that they said I think 90% said they'd be unwilling to put their child into a fully automated car and let the car drive their kid or kids to school. And so that's an interesting perception, and it probably won't be until they've actually been in those vehicles eventually in the future themselves and have experienced the reliability of the vehicles and how they work, that they would allow their kids to get into a self-driving car. And so, we can totally understand that, I think, from first principles. Interestingly, less than half of the people we surveyed were willing to pay more for self-driving vehicles than for their existing car. So that's telling us that, at least half of the people want automation just to become a part of the future, and don't want to have to pay any more for it. And they shouldn't have to pay any more for it. So that was quite an interesting finding. Most people agreed that there are many potential benefits from automated vehicles, and we've talked about those during this podcast. And most people were comfortable with driverless vehicles controlling most driving functions, even though, as I said, most people haven't actually experienced them. But interestingly, when we talked about the different things that automated vehicles can do, they were least comfortable with cars changing lanes by themselves and following cars ahead too closely. And again, that makes total intuitive sense. These are two functions that, if they don't operate perfectly, could kill you. The car could have a head-on crash, or it could have a massive, rear-end crash. So these things probably weren't that surprising to us. I think what was surprising to us was that most people said that they'd spend their time mostly observing the scenery and interacting with passengers in a fully self-driving car. So I thought, they'd probably say, well, I'll probably do some work in the car, and I'll play games, and I'll do these things. And so what this suggested to us was that during the early phase of deployment of these vehicles, people are probably still going to want to look outside, at least intermittently, to check that the automation is controlling in the vehicle the way they would expect it to. And so they're probably, at this stage of the evolution of these vehicles, not quite ready to turn their heads and just let the vehicle do what it wants to do. Interestingly, we found that people are more comfortable about taking control from the vehicle than giving control to semi-automated vehicles. And that can be a problem because, as I think we've talked about, if the vehicle issues a takeover request and says, I want you to take back control, we want to be sure that people are going to take back control because the vehicle will want them to take back control for a reason, the reason being that the vehicle can't control itself, and so it needs human intervention. And as I alluded to before, we found most people would like to drive a fully self-driving car manually from time to time. I think they're probably the main findings that came out of that survey. There were some areas in which males and females thought a little differently about AVs, but I won't sort of go into that. But if any of your listeners are interested, I can provide access to the reports from this survey and a journal article that we wrote. There are a couple of other issues I just wanted to mention. One is workload. Automation can be problematic if it reduces workload during already low workload periods, which can lead to a loss of arousal and make people sleepy. So, and the human factors profession has been interested in this for a very long time, this whole issue of workload and automation. the problem is you've got things like adaptive cruise control on highways that you can use on a highway, or even cruise control, and it's automating part of the driving task, but it's automating it in an environment that's already very boring. Sadly, driving on the Hume Highway, which I did recently from Melbourne to Canberra, isn't exciting as driving through the Alps of France or Italy. So it can have sort of negative consequences sometimes when used in environments that in which workloads are already quite low. The other thing too is, and I've done a bit of research on this myself, once you start automating parts of the driving task, like in level 2 vehicles that are out there at the moment, and more so level 3 vehicles, which I'm sure will emerge very soon, that can actually encourage drivers to engage in secondary tasks. And if they're engaged in a secondary task that's unrelated to driving while the automation's on and the vehicle issues a takeover request, and their head's in la la land as they're watching a video or doing something else on a mobile phone, that could quite adversely affect their ability to take back control of the vehicle in a timely way and in a quality way. So workload's an issue that we think about as well. I think the final point I wanted to make is a comment on ethical issues, which are also, ethical issues are human issues. And one of the issues that's been looked at in relation to automated vehicles by ethicists and philosophers is what they call the trolley problem. And the issue here is how to design a decision algorithm in a automated vehicle, a fully automated vehicle, in the face of an inevitable crash. So you've got a fully automated vehicle that's it's going to have a crash. And if we were driving the car, we would make our own decisions on the run about what we're going to do, probably mainly to protect ourselves, but as I said before, ultimately probably to protect others if we can create together a crash that doesn't kill anyone. And there was a researcher, Bonifom, just a few years ago who posed some alternative automated vehicle algorithms for controlling an imminent crash to a group of participants in an experiment. And it was quite interesting. So, for example, Bonifom said to participants, there's a driver approaching a group of pedestrians, or a vehicle approaching, a fully automated vehicle approaching a group of pedestrians. Should it drive into the pedestrians and kill them, or should it veer off the road and as a consequence you get killed as an occupant because you hit a tree and it's unavoidable that you'll hit the tree. And most of the respondents opted for what Bonifom called the utilitarian design option. In other words, they said, well, what the car should do is to be programmed through its algorithms to minimise the number of injuries to all of the parties in the crash, to the driver and also to the pedestrians. But then Bonifom said to them, well, if you bought a car for yourself, how would you want the algorithms designed? And the interesting thing was that they said if they bought a car, they'd want it to be programmed to minimise total injuries and protect its occupants at all costs. So if it's their own car, they had quite a different mindset about who it was going to protect. It needed to protect number one, which was them. And so the people in that experiment disapproved of governments mandating the utilitarian option, which was that the vehicle should be designed to minimise injuries to all parties in the crash. So these are some of the ethical dilemmas that we face in the human issues, and they're ones that from a human perspective and from an ergonomic perspective, we have to consider in working with engineers who are, when you think about it, making very significant decisions in programming these automated vehicles to behave in life-threatening situations. There was one other issue that I wanted to talk about briefly, again, another human factors issue, which is very close to my heart because I'm doing research at the moment on this topic for a major car company, and it's motion sickness. And motion sickness, as some of your listeners might know, occurs when movement is out of control of humans and there's a reduced ability to anticipate movement. And so if you're sitting in an automated vehicle, fully automated vehicle, for example, as a passenger, and you might even be in the driver's seat, you won't be controlling the vehicle. And a study found not so long ago that up to 10% of American adults are expected to experience motion sickness in automated vehicles because they're no longer in control of the vehicle and can't anticipate the movement of the vehicle. And so motion sickness could reduce passenger acceptance of these vehicles and in fact, the utilisation of autonomous vehicles. And there's even evidence that some populations, for example, Chinese people in China are more prone to motion sickness in automated vehicles than in other cultures, or just more prone to motion sickness per se. So this is a big issue, and this is one where an area I'm currently working in. Probably people don't realise it, but automated vehicles of the future and fully automated vehicles will almost invariably be electric vehicles, battery electric vehicles, because the battery electric vehicle is, of course, digital. And so if you're developing automated systems that are digital and require digital communication within the vehicle, they will be the platforms for automated vehicles. But battery electric vehicles, if you've driven in a Tesla, for example, are very powerful. They're very torquey, massive acceleration, and it's those characteristics of the vehicles that can make people ill. And so we have a lot of people in our profession who are, well, not a lot, but some who are working with major car companies to try and improve the design of the vehicles so that either through the design of the human-machine interface in the vehicle, through displays that make it easier for people to anticipate, for example, the movement of the vehicle, the orientation of the seating in the vehicles, or even adjustments that can be made to the kinematic movement of the vehicle can reduce motion sickness. So it's a very real issue, and I've actually experienced in my own car when even though it has a low level of automation, it's a real issue. So I think I've pretty well covered now all the issues I wanted to cover and answer your question, Sharon. As you can see, the human factors and ergonomics issues that are raised by the rollout of these partially and fully automated vehicles are many and varied, and so there's a lot to do. It's keeping us all busy in the profession.
You've given us so much to think about there, Mike. I'm wondering what the HFE community currently is doing to address these issues, and is there something else that they should be doing?
Well, thanks for asking that question, Sharon, because I think we just had to finish off this podcast with a question like that. The human factors and ergonomics community has contributed and is contributing in many important ways in not only identifying the challenges and issues associated with the deployment of these vehicles, but also understanding the issues and that I've talked about in the last part of the podcast, and addressing the issues. And I'll give you some examples. So in one important area, which I mentioned, which is research and training, We've been doing a lot of research on the various topics that I've talked about just now. In the area of training, people in our profession are designing and developing training programs to equip drivers with the necessary knowledge and skills to safely operate vehicles that have driver assistance systems and high levels of automation. So that's all happening at the moment. I alluded to that report that I wrote not so long ago on this topic. So we're working with a range of people, driving instructors, point of sales staff, and that sort of thing, to make sure that people understand how the systems work and what their capabilities and limitations are. Another area in which our community is very active at the moment is in the development of human-machine interface design documents and standards. And so in the area of human-machine interface design, the sorts of issues that we're working on in conjunction with the engineers and others who are designing the vehicles is decide on which functions should be allocated to humans and to the automation, at least in partially automated vehicles. We are working with people in developing design documents and standards, developing recommendations for the design of displays and controls and warnings that occur in the vehicles. So with these advanced driver assistance systems, as I mentioned earlier, you get a series of warnings. For example, if in a level 2 vehicle, you take your hands off the wheel every 30 seconds, the vehicle will tell you to put your hand back on the wheel if you use that automation in that way. And you've got to make sure that, in that case, the warnings are designed in a graded way that attract the driver's attention, and they need to be timely so that, they get their hand back on the wheel when they need to get their hand back on the wheel. We also do work that feeds into design standards on increasing trust, minimising workload and minimising distraction, and optimising and maintaining situational awareness in these vehicles. There's a lot of work we're doing at the moment with vehicle manufacturers to optimise the transfer of control from the vehicle to the driver and vice versa. So if the car does want the driver to take back control, how do you design warnings and displays that orient their attention, for example, back to the road and allow them to take back control in a timely manner, and to make sure that they have good situational awareness of what's happening around them when they take back control. So a lot of work's going on in developing standards for the design of the human-machine interface for specifically that purpose. And there's also some standards development work going on in how to design these vehicles for people who are fitness impaired and disabled. So that's more a physical ergonomics issue of if someone's going to hop into a fully automated taxi vehicle and they're in a wheelchair, how does that work? How does the vehicle support them if there's no one else there to help them into the vehicle and during egress when they need to get out of the vehicle? So quite a bit of work's going on in the area of design guidelines and standards, and many of us around the world sit on committees, and on at least 3 committees in that area. Another area in which we've been active as a community of human factors and ergonomics professionals is in providing input to policy and regulations around the design and deployment and testing of automated and autonomous vehicles. So frequently our profession's sitting on committees with governments and providing policy advice on what they should be doing in this area, because regulation around these vehicles is quite complicated. There are all sorts of issues to do with, who's in control of the vehicle when there's a crash. How do you establish who was in control at the time of a crash? Was it the vehicle, the driver? Who's liable in the event of a crash? There are regulations around the design of these vehicles. We have Australian design rules, and the human factors community, plays an important role, actually, increasingly in the development of policy and regulation. Evaluation is very important too. One of the things we're taught as human factors professionals is to be able to evaluate and quantify the impact of the changes that we recommend to the design of artifacts that people use, and that includes vehicles. And so there's a lot of research that we've done in our community to assess and quantify the impact of vehicle automation on both human performance and safety. And so earlier on, I talked about some of the safety benefits that we know exist when people are using advanced driver assistance systems, and that's because people like us in our community have done that research and can quantify the impact that these systems can have, not only in making vehicles safer, but also making them more satisfying to use, because ultimately the more satisfying they are to use, the more willing people will be to accept them and to use them, as I talked about before. And so I suppose it sort of leads me to the very end of the podcast, and the question that I was sort of thinking about in working out how to finish the podcast off was, well, what else can we do? What's the future, for our community in this space? And I think it gets back to what I talked about before, that as a need, that there's going to be a need in the future for us as a human factors community to focus not so much on the interaction between drivers and partially automated vehicles, which is what we've mainly been doing at the moment, because we don't have fully automated vehicles out there. And it's only really with these partially automated vehicles that we have all of these issues that I talked about, things like transition of control and acceptance and skill loss and that sort of stuff. But in future, I think it's going to be our job to focus more on the interaction between passengers and fully automated vehicles that are driving themselves all of the time. So we're going to be needing to think about more so about the user-centered design of these interactions between passengers and fully automated vehicles. And so the sort of things we'll need to think about, and I've alluded to one or two of these before, is that we'll need to focus more on the ergonomic design of the interior of the vehicle to make it fit for purpose for people who don't have to drive anymore. And the sort of things that are important there are things, like I said before, things like, how do they comfortably get in and out of the vehicle? If they want to make an unexpected stop to pick up a pizza from somewhere, how do they convey that to the vehicle? And how does the vehicle respond accordingly? If they feel ill for some reason and want to get out of the car, how does that work? So we've got to think about the fact the vehicle's driving itself. There's not a human driving it anymore, but a passenger has to interact with that vehicle in some way, both physically and verbally or psychologically, if you want to put it that way. And so that's exactly bread and butter stuff for human factors and ergonomics people. It's communication, between the vehicle and passenger. If people are feeling unsafe or if they're feeling unwell, all those sort of things. So it's really this whole issue of, understanding the interactions that are going to occur between the human and the car. And as we always do in human factors, sort of thinking about what can the driver be doing? What can the vehicle be doing to optimize that interaction? And how will the interaction work? What's the best way to make it work ergonomically? We're also going to need to focus in the future on the way autonomous vehicles interact with each other, with other autonomous vehicles. And as I mentioned before, how they cooperate with other road users as they become increasingly connected. And we're going to need to understand what the unintended consequences for humans and vehicles and other road users will be, or may be, that this connectivity brings about. So we've already had the experience of interacting with battery electric vehicles, which are silent, and we've had to learn instinctively to sort of be listening out for vehicles that don't quite sound like an ordinary vehicle, and so that we don't get hit suddenly by a vehicle that we couldn't hear and didn't know was there. And then similarly, the drivers of battery electric vehicles are having to sort of change the way they drive too, because they're aware of the fact that people can't generally hear them, and so they need to drive in a way that they need to self-regulate their own driving behaviour to, make sure they don't hit people who can't hear them. And in the same way, fully autonomous vehicles in future won't have a driver in them. And so the vehicle is going to have to sort of be designed to be able to communicate with road users as it's driving along, and to know how other road users behave on the road, and to be able to predict the way they move and to anticipate their movements, and to be able to cooperate with other road users to prevent crashes. And again, that's what a lot of people are calling in our industry external HMI. So we've, in the past been concerned with the design of the interior of the vehicle from a human-machine interface perspective, but now they're using this buzz term external HMI, which is, what can you do to the human-machine interface external to the vehicle to allow the vehicle to be able to communicate its intentions to other road users. So, could you use the headlights, for example, of the automated vehicle to smile to someone, or to, indicate in some way that they can't see them? It's all these sorts of things. So these are new, interesting areas. It's also likely in a future world of connected automated vehicles that there'll be a need for ground traffic controllers, just like we have air traffic controllers, who are going to need to monitor the transport network for autonomous vehicles that have, perhaps broken down due to sensor failures or faulty algorithms or abuse by passengers, and that in itself, again, for us, raises a whole new field of human factors and ergonomics issues around how ground traffic controllers themselves will communicate with automated vehicles, and will communicate with vehicle passengers that are sitting in those vehicles, and also the design of the working environments for those ground controllers. So just as in an air traffic control environment, where human factors and ergonomics specialists have been involved for decades in helping design the work that they perform to make sure that they're not overloaded, they don't have two simultaneous decisions to make, and all those sort of things. It's now going to become a whole new area of ground control for vehicles. And so a lot of the principles and research and advice we've given air traffic controllers in the past to make their life easier and to make the skies safer will apply here. So I think finally, we can safely say, I think, that for as long as humans continue to design and program and use and monitor automated vehicles, especially fully automated vehicles, that the human factors and ergonomics community will need to be there to ensure that the humans are at the very centre of our thinking, and that the entire transport system is fit for use. People often think that once you get the human out of the loop and you've got an automated vehicle driving itself, that the human's not your centre of analysis anymore. You've taken the human out of the loop, and that's it. You've solved the crash problem, especially once they become connected. But as I've said, you're still going to have humans in the loop who are going to be creating and refining algorithms. You'll still have humans in the loop that are remotely monitoring, the activity of these vehicles out there. So as human factors and ergonomics professionals, we'll have a lot to do in this area for a long time. And so, in conclusion, probably just make 3 points. I think partially and fully automated vehicles, both ones that aren't connected and especially ones that are connected, in future will have great potential to improve traffic safety and mobility and provide other benefits that we've talked about. As I said, the actual safety benefits of more highly automated vehicles, those at what I call level 3, 4 and 5, we currently don't know what exactly their safety benefits are. We know much more about the safety benefits of vehicles with what we call level 2 automation, things like adaptive cruise control and autonomous emergency braking and those sort of things. And finally, there are some significant human and technical challenges that we're going to have to overcome before autonomous vehicles, especially fully self-driving vehicles, are capable of maintaining at least the level of safety of the average human driver today. Because, ultimately, you'd have to say, if you can't have a fully automated vehicle that drives as safely or more safely than a human driver, what's the point of having such a vehicle?
Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.